Welcome back. Today, what we are going to be talking about is trigonometry. Um, Trigonometry is a very important part of mathematics, and we're going to be dealing with the ratio, the general angle, and graph identities of trigonometry. Firstly, before we can go into trigonometry, we have to know what an angle is. When we're talking about angles, angle is represented in theta. Angles. Let me write the topic down. Trigonometry, and we're dealing with ratios, uh, ratios, the general angle, ratios, the general angle, the general angles, and graph identities. Graph identities in trigonometry. So back to our angle. If you want to find out an angle, can you imagine a wristwatch? This is the way the wristwatch moves. This is clockwise, and that's why they say it's clockwise. But when you are moving like this, can you see it's opposite to the clockwise? This is called anti-clockwise. So whenever you see in trigonometry that the angle in an anti-clockwise way is moving, that means you should take it this way. Now, when you're not talking about angles, this is the x-axis. This is the x-axis. This is the y-axis. This is the y-axis. This is the x-axis in the positive side. This is the y-axis in the positive side. This is the x-axis in the negative side. And this is the y-axis in the negative side. So now when you're not talking about angles in trigonometry, you draw the graph, you draw the x, y. Of course, you know this is the negative side, which is minus. This is a positive. This is minus. This is a positive. And in trigonometry, you move anti-clockwise. So the take for instance, during your movement, you have this as the length of this this radius, because remember that it's a circle. We are taking it like a wristwatch. This is the radius, this is the arm, this is another radius. From the center, let's take this radius to be 1. Then when this radius move, when you're moving your arm in a clockwise direction and this radius move within an angle, within that's moved from the central, which is the diameter of that particular circle, it forms at a particular degree, that degree from the center is called an angle. An angle can be measured by called theta. 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 So when you hear somebody saying theta, he's talking about the arm has moved in an anti-clockwise direction at a particular theta. And this is the degree of movement. The right degree by putting a small zero on the theta. This can be like 45, as we're looking at 45 degree. And then also we have 4 quadrants. This is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. Now, when we are now talking about the three main trigonometry ratios, we have the sine, we have the cosine. That is, cos is the same thing as cosine. Sine is sine. And the last one is the tangent. Tangent. Now, let me redraw this angle. Let me redraw this triangle out for you. Okay, we can still use this. Remember I said this is x axis and this is y axis. This can also be redrawn like y axis here. Let me draw it out again. And this is theta. This is y axis, this is x axis. And let's assume this is 1. So when you have y, the sine ratio is always equals to adjacent, opposite over hypotenuse. This is hypotenuse, this is opposite, and this is adjacent. So when you have sine, this is the formula, which is the same thing as y over 1. Then the sine theta, we can now add theta to this, and that is how we can define the angle. The same thing applies to the cosine. Cosine is the same thing as adjacent. Over hypotenuse. And then you can add the angle. And you can have the tangents to be opposite over adjacent. Now, these are the three ratios that is being applied in trigonometry. This is going to be helping us to be able to find the angles and know the directions, know the angles of degree, the degree in which a particular projections is being done when using trigonometry. Thank you.